Hello everyone. Today is a bit of a special TFA session. We're actually going to have scheduled an hour and a half session to cover two topics. One is the FFA SPMC at EL3, which Marc and Olivier will be presenting today. And then following this, we'll have another relatively shorter session on DRTM that goes along with some patches that have been recently uploaded for review, but more on the DRTM later. That'll be presented by Manish Pandey, and we can start with this session. Please take it away, Marc and Olivier.
Okay, great. Thanks, Joanna. Yeah, so today we just want to give a quick overview of FFA and the work we've been doing to enable an SPMC at EL3. So I'm just going to start with a quick overview of what FFA is, just in case not everyone knows, and what the problems are that we're trying to solve. So FFA is the firmware framework for the ARM A profile, and it's a specification that is aiming to provide a standardized interface between two sandboxes, for example, VMs or SPs. So the interfaces that we aim to provide a consistent experience for are in three key areas. These are discovery. So this is to allow a partition to discover other partitions in the system and various properties about them. For communication, this is to allow a standard way to exchange messages between partitions. And memory management. So this is to facilitate the sharing, lending, and donating of memory between two or more partitions in the system. So I'll be included a link in the slides just as a link to the full spec if anyone wants to take a look. But today in this presentation, we're going to focus on VM to SP interactions, more specifically a Android VM in our normal world and a trusted OS as RTE in the secure world. Okie dokie. So, nope, hang on. Right, okay. So, the question here is, why do we need FFA? So, as we've tried to highlight in this diagram, currently without FFA, for each individual TE implementation, we require TE specific drivers in pretty much all the different software components in the system. So this is in the OS, in the hypervisor, in the EL3 firmware. So this adds extra code and complexity to all these different components, just to essentially perform the same functionality for each individual TE's custom protocol. So just an example, if we take a DRM, a secure video path use case, essentially the requirements here are to provide the trusted operating system with some memory that it can use for a given use case and ensure that it's not readable by the OS, in our case, Android. So at a high level, it's done by allocating some memory in the normal world from Android and then using some SIP-specific SMCs to program the IO MPU to restrict access, so only the participants can actually access this memory, and then informing the TOS of this. So there's only a certain amount of ways this can actually be achieved. But each implementation from just operating systems and silicon vendors have their own way to accomplish this. So as I said, this results in a lot of code duplication that is subtly different, but they're all trying to achieve the same outcome. So one of the aims that FFA is trying to solve here is to generalize all this and provide a simple interface and programming model that can be reused The programming of the actual hardware to restrict permissions can be left as an implementation detail, but this means the amount of custom code is minimal and can be abstracted away. So another benefit of having a standardized interface means that configuration changes can be more transparent. For example, if the normal world has migrated, it doesn't need to be aware of additional changes in the secure world as we maintain this standard interface between the two. So this should help provide a migration path for pre-8.4 platforms. So without SEL2, migrate to post 8.4, so with SEL2 enabled. And also another potential benefit here is that by using these set of standards, we can add portability to a TESP, which means it might even be possible to run this in the normal world under an FFA-aware hypervisor. So that was how things looked without FFA, and then with FFA, we can see we've replaced all of the TE-specific drivers with a single FFA driver in each of these components. This means that, for example, a VM or an SP can use the FFA driver to talk to and interact with any other FFA-enabled partition in the system via these set of standard interfaces. And then any sort of higher level protocols can be based on top of this. What this means is that, for example, the hypervisor with its FFA driver no longer needs to be aware of the higher level protocols and can just support FFA as the transport layer. And then we've got the same story for EL3. So instead of having a custom dispatcher in EL3 for each trusted operating system, for example, the Opera dispatcher, the trust dispatcher, and so on, we can just rely on a standard generic SPMD component, which can forward FFA calls as appropriate. And then finally, we have the SPMC. In this case, we've got it living in EL3, and this allows, this provides a logical isolation for the SP and maintains the standard interfaces that we've mentioned. Was there a question? Nope. Okay, cool. So yeah. So the benefit of doing all this means that these drivers can be agnostic to the partition or partition manager implementations running in either world. All they need to do is just implement the set of FFA standards. So I mentioned in the previous slide, this was for an SEL1 SP, but in the FFA spec, we also support deploying an SEL0 partition directly under an SPMC. So currently we have the SPM dispatcher, which supports running an SEL0 partition under directly under EL3. But by enabling the SEL0 partition to use FFA, we can run this directly under the EL3 SPMC, and again, no longer require this separate dispatcher implementation. So just a couple of points behind the motivation of implementing the EL3, the SPMC in EL3. So yeah, so the EL3 SPMC is the implementation of an FFA SPMC directly in EL3 itself. We've added experimental support for this in Trusted Firmware A version 2.7 that was recently released. So the aim here is to help support systems without SEL2 and provide a migration path on the way to running a trusted operating system or any other partition under SEL2. And then to help with this, we've been working to help try and keep alignment between Hafnium and SEL2 SPMC and the SEL3 SPMC. For example, the SP manifest bindings and other major features. Also, as part of this work, we've been collaborating with open source trusted OS vendors and other partners throughout the review process to ensure that the appropriate features from FFA have been supported, and we're able to get the trusted operating system running with this configuration. So just as an example, those familiar with Opti, mainly the Opti X test suite. So we've been working with Lenaro and have reported success running the test suite under the EL3 SPMC, and similar ongoing work with Trusty running in this configuration as well.
Hey, Mark, quick question.
Sure.
Oh, okay, never mind. I saw the diagram wrong. So currently you only have support for the left side diagram, right? Or is even the Secure EL0 SP
yes,
model
yes,
supported?
You're correct. At the moment, it's just SEL1. SEL0 support is in the works. I'll have a quick slide on that later, but yeah, that's the current state of things.
Thanks.
Cool. Yeah, so just going to go a quick run through of the currently supported features in the SPMC. So yeah, so currently we just have support for a single multi-core SEL1 SP. Support for SEL0 partitions is still ongoing. We have support for direct messaging, which is register-based message passing between different partitions in the system. We also have support for a logical EL3 partition, which is a simple entity that lives in EL3, and it can be communicated with via direct messaging, just like any other partition. We also have partition discovery. So this is via partition info get API. So this allows discovery of partition IDs and other partition information for both the EL3 logical partitions and the SEL1 partition.
Hi there.
Hi.
Sorry, quick question. What are the use cases for logical EL3 partitions?
So it could be any sort of basically implementation defined behavior that partner may want to introduce. So it's sort of just, yes, it's just sort of an additional entity that you can communicate with via whatever messaging or whatever protocol you want. And then it can execute and provide, perform whatever action is required.
So just to add to what Mark said, the intent behind, the other intent behind logical partitions was that we do want to minimize the amount of code that runs in EL3 over a period of time. We think that's beneficial. When I say we, like this is from ARM's perspective, logical partitions allow us to say package, say platform specific code in EL3 as a secure partition. So basically you can talk to this code, which has been abstracted as a secure partition using FFA ABIs. This code can potentially talk to other partitions, and this enables a migration path that if now this code needs to be moved out, say into a separate secure EL1 partition, when say virtualization is enabled, when we have secure EL2 enabled with Hafnium, the other project that we have in trustedfirmware.org, then it makes it easy. So as Mark said earlier, basically it enables the migration path. So the logical partition support is one aspect of enabling that migration path.
Okay, that's good to know. So I think it'd be helpful if this intent is explicitly mentioned, because otherwise it can be interpreted in the other direction as well. So basically bring, EL1 components into EL3. So
right,
which is not, I guess, absolutely the opposite of what you said.
Yeah, no, that's a fair point. To be honest, we didn't that didn't cross our mind, but that's definitely food for thought. Yeah.
It does provide paths both ways. So I think it would be important to mention this very clearly.
Okay. Yep.
One question, right? So in this logical EL3 partition, can both normal world and say secure world SPs that run either in secure EL1 or secure EL0, can they communicate with this logical EL3 partition? Using direct messages, for example,
Yes,
or is it only normal world to EL3?
Yeah, no, it should be both. So the logical EL3 partition gets its own partition ID, so it should be addressable by any other partition in the system.
Okay, is there a reason a logical EL3 partition is tied to the EL3 SPMC? I mean, in theory, you can. Yeah, I'm wondering if there's a path to support the logical EL3 partition, say with an EL1 or secure EL2 SPMC.
It gets a bit strange then, Raghu. The basic idea over here is that the concept of logical partitions in the FFA spec, it is basically a partition that's at the same level as the SPMC, at the same exception level, or it could be at a lower exception level. So if we have, say, hafnium and we have a logical partition at EL3, then firstly, we have that kind of defeats the purpose of migrating code out of EL3. We have compartmentalized it, but we're still leaving it in EL3. But secondly, even if just for the sake of argument, we were to support that, from the SPMC's perspective, it expects communication either from other secure partitions or from the normal world. And now this logical partition is like another abstraction, right? So it makes things a bit weird. So yeah, I mean, that's why we haven't kind of gone down that path.
Okay, yeah. That makes sense. Yeah, it's really that it has to be in the same exception level as the SPMC. Yeah. Okay. Thanks.
I have one more question. Since you mentioned that it is there to provide a path for things to be migrated, platform-specific things to be migrated out of EL3 into lower ELs. Do you have any specific functionality in mind as examples of what could be migrated out?
Well, Marc, you want to take this? Shall I take it?
Yeah, go ahead.
All right. Yeah. So thanks. So one example of functionality is, say, the access control mechanism, right? Like, say, if you have a completer side access control mechanism, a completer side filter that needs to be programmed out of EL3, that could be moved to another partition. But yeah, basically it's platform drivers, right? Like we do envision a world where in EL3 firmware, we will have, say, implementations of the standards and like basically bare minimal platform code, what is absolutely required. But yeah, if there's a driver which needs to be assigned a device and it needs to handle an interrupt, and there's no particular reason why it needs to be at EL3, that would be a good candidate to move into a logical partition as a first step. And then as a second step, move into a secure EL1 partition.
Right, but do we right now have such drivers, like existing concrete examples, or are you thinking about potential cases in future?
Well, we have discussed this with some other partners, so I cannot disclose the details, but yes, there are some drivers where, like, basically you could think of this as in downstream TFA, there are drivers that they can migrate. But we have, from our perspective, it's like we provide this programming model that through a manifest, you can assign a device to this partition, and the partition is able to handle its interrupts. And this is the way the interrupts can be handled, and so on and so forth. And yeah, like, so we think that that generalized programming model, it should be easy to migrate the drivers out.
Got it, understood. Thank you.
Yeah, thanks.
So, Achin, this EL3 logical partition, do you envision this as a blob of code, which I just, once it is ready and functioning as expected, I just take it out, compile it as an EL1 partition and get it running? Or do you think there will be additional work that needs to be done? I mean, for example, does the EL3 partition have its own manifest? Or that would be an additional thing that needs to be done when we move it to EL1?
So, Mark, correct me if I'm wrong, but at the moment, the manifest-like properties of an EL3 logical partition are basically hash defines, right?
Yeah.
Yeah. But yes, when it is migrated, Varun, we would expect it to have a separate manifest. I mean, it could be a case that you take this code out of EL3, we have the test secure payload that we package with TFA. Mark will be talking about that in a bit as well, I think. Yeah, the code can move into that partition, something on those lines. But yes, definitely the manifest will be there once the migration happens. I guess
just one other.
Sorry, go ahead, Rahul.
No, yeah. Varun, does that answer your question? If yes, I'll ask my question. Okay.
Yeah, nothing else from me.
Okay. Quick, maybe there's a detail, right? We can talk about it later. How does your SPMC distinguish that, that it needs to, call down into a lower EL or an, or forward it to EL3? Is it some property in the manifest, or
Mark,
or does it pre-know the ID? Yeah.
So you mean like how it distinguishes between forwarding a direct request to either an SEL1 partition or the EL3 partition?
Yeah.
Yep. So the SPMC knows which IDs are corresponding to the logical partitions. So it looks up the ID and either calls into the direct request handler, the logical partition is registered. Otherwise, it would look up the SEL1 and then forward it down.
Okay, thank you.
Sure. Okay, cool. The next major feature is on the memory management side of things. So in the EL3 SPMC, we have the concept of, we have the implementation for lending memory and sharing memory. So the former is when the lender loses access and then the borrower gains access. And also for sharing, both the lender and the borrowers both have access to the given memory region. The implemented ABIs are listed here. And then we've also got the support for fragmented descriptors with FragRx and TX. So another feature that we have is for multiple borrowers. So obviously at the moment we only have the single SEL1 SP, but this is to support the use case where we want to share or lend memory with one or more VMs in the normal world, as well as the SP itself. And then finally, we have implementation defined hooks in the lend and share and reclaim handlers. So this allows for any sort of platform dependent behavior such as MPU programming to do any sort of access permission control. The next thing we have is power management. So we support hot plugging from the normal world, and we allow an SP to subscribe to certain power events via its manifest. So for example, before like CPU off, CPU suspend, resume, the SPMC will notify the SP that this power event is about to happen, and allow the partition to do any sort of bookkeeping or maintenance it needs to do before the power events happen. So we also have support for forwarding interrupts to the SEL1 partition. and allowing signaling of completion. And also performing of the state tracking of the partition, both for interrupt handling and other FFA APIs, just to help keep track and make sure everything is working as it should be. And then finally, we have the FFA boot protocol as per the v1.1 version of the FFA spec. And we use this to provide a copy of the SP's manifest directly to the SP itself, so it can retrieve any additional information it may need. So yeah, as I mentioned before, currently we just have the SEL1 support. There's currently ongoing work within ARM to support a single SEL0 partition. So this is, yeah, as I say, currently under development and should be going up for review within the next week or so, which should be quite shortly. So currently, we've been told that there's, using this new functionality, they've managed to validate both secure boot and RAS use cases. So yeah, this is coming soon. Finally, just a quick an example of how you would build the EL3 SPMC. So just with the traditional TFA build options, we are, as I mentioned, we're using the SPMD as our SPD. This is running without SEL2, and we are enabling the SEL3 SPMC. So a copy of the build commands and a few other bits of information are available in the TFA documentation. Finally, just a quick example of what some boot logs would look at when things are up and running. So as can be seen, the first section here is the SPMC will call into a logical EL3 partition and allow it to do any initialization it may require. It then moves on to preparing the SEL1 SP environment. So it reads this manifest and populates the boot information before jumping into the SEL1 partition itself to allow it to perform its initialization. If this is signaled as successful, then the SPMC hands off and lets execution take over to the normal world as usual. So yeah, so that's it from me. I'll hand over to Olivier for some more TFA details and the next steps.
Hello, can you hear me well?
Yep.
Yeah.
Hear you.
Yep.
Great. So that's a quick recap from the TFA maintainer perspective on this project. So as Marc mentioned, the EL3 SPMC core changes were merged in the TFA v2.7 release in May as an experimental feature. So highlighting here that it's multiple teams collaboration between the ARM architecture team, the TFA team, and obviously partners for reviews. That's a good amount of 45 patches developed, reviewed, and merged. So the support is a single SEL1 partition, so mainly for supporting the TE, and complies with the v1.1 specification. So beyond the SEL0 support that Marc mentioned that would land the public reviews shortly, obviously partner contributions are welcome for new features onwards. So that's the current state. As for the next couple of weeks, we are working on lifting the experimental feature flag in a way and make it more production friendly. mainly through testing. So we have a couple of test and CI changes under review, development and review. So the concept here is to reuse the legacy test secure payload existing in TFA to adopt the FFA protocol. And on the non-secure side, there is a Linux-based test driver that the architecture team is providing. We expect to review and merge, to complete the review and merge for those changes by this month, actually. In parallel, we're working on running this SPMC implementation against the FFA architecture compliance suite. So the test suite runs. There are a few findings for which fixes will be proposed in the coming weeks. Nothing blocker or critical. And the test results and way findings, if any, are planned to be documented. Worth noting also a few platform changes related to the IK 960. So one partner is using this board as a bring up. So there are 7 changes under review on top of the upstream SPMC. And by August, we plan for documentation updates like threat model and design document. So that's the current status as of June. In the next slide, I'm just hinting on something that Marc mentioned, in the sense that we want to maintain the SEL2 SPMC on par with the features that the EL3 SPMC implements. So that's a one-way feature catch-up from EL3 SPMC to SEL2 SPMC. So what happened is that there are a number of features in the EL3 SPMC originating from the FFA 1.1 spec that were picked early and are not necessarily present in the SEL2 SPMC. So the intent is to maintain a smooth migration when it happens from the EL3 SPMC to the SEL2 SPMC for an SEL1 partition or SEL0 partition. So we have a short list of identified items where we want to do this catch-up. So that's this scenario of memory sharing to multiple borrowers. So mainly normal world endpoint sharing to one secure partition and multiple VMs, making the memory sharing structures forward compatible as described in the 1.1 specification, implement the security state for a memory region passed in the memory retrieve response, implement bits of the power management at runtime, and make sure the SES results are consistent across the 2 SPMC implementations. That's all I had, really. So if you have questions, don't hesitate. Thanks.
So I don't have a question. I do have a couple of comments, right? So the FFA spec is starting to, I don't know if it's starting, but it's starting to add a decent bit of ABIs, right? Especially around memory sharing. So it would be good if both the EL3 and SEL2 SPMC, makes including or removing memory sharing APIs configurable, right? So that allows for reducing potential attack surface, right? If we have no use for mem share, I'd rather rip out all that code, say from halfname or the EL3 SPMC. So that would be something to think about as we do the catch up.
I'm not sure I exactly get the query here. Do you mean that we should have configurability to remove the memory sharing implementation from one SPMC?
Correct. Yeah. So when I do FFA features, I want to be able to have the option say in half name. If I have a use case, I can advertise support for mem, lend, share, all the other mem APIs. And if let's say I turn off a build flag, and FFA features now does not report that, and all of that code is ripped out. It can start out with all or nothing, but specifically for me, at least I don't know of a use case for us where lend and donate really is required, right? Sharing, yes, I can see. So in an ideal world, I'd like to just see only the share API supported and not the other stuff, and maybe that requires some spec changes as well.
Okay.
And the reason for this is it's the APIs and the implementation is non-trivial, right? Especially the state tracking. So these are not primitive. These are really full-blown, featureful FFA APIs.
So from what I understand, it's actually not omitting all of the memory sharing implementation, but selecting part of it, right? At least either keep the memory sharing or implement everything from a build flag.
Yes, you can start off with all memory. Correct. That's my use case, right? But maybe a better way to start initially would be, yes, memory sharing is supported. I'm sorry, memory APIs are supported, memory APIs are not supported, and then you can make it more finer granularity if possible.
Okay.
So, Raghu, so I get the intent behind keeping support for memory management in versus not keeping it in case in a system where we know that we'll be relying on static carve-outs of memory for any memory that's shared between partitions and such. But keeping in mind that the memory management operations pretty much share all the data structures, the ABIs are pretty much the same, and state tracking is required for memory sharing as well, because we do have to enforce the rules like if a memory is shared between two partitions, it shouldn't be shared with another partition and such. I'm thinking whether we would really make any savings by removing donate and lend.
At least my reading of the implementation was, yes, because there are all these APIs, there are a bunch of case statements and if else's that say, if this check these rules, if that check these rules, right? You can just get rid of all of that, and then it's a more linear path, a code path to read. But yeah, I think I see what you're saying too.
So it's more like a security threat model. I mean, removing code in the sense that the less you have code, the more this is robust and secure.
That's mostly it, right? And it's also easier to follow and easier to reason about when you read the code. At least that's the intent. So right now, like Achin said, yes, it's one function call which handles all of these different ABIs, and there are semantics related to each of these that's encoded in different portions of those functions and code. It's a little hard to follow, and maybe that's why I'm nervous.
Yeah.
In an ideal world.
Go ahead, Raghu. Sorry.
Yeah, in an ideal world, the FFA mem API for me would be share page, right, with one borrower, and all of the rest of the logic would live in whoever is either sharing or lending. But I'm sure you guys thought of that and decided there's a good reason to provide a higher level API. So for me, that would have kept the SPMC implementation simple. And we can take this offline, right? It's a detail, but
yeah, I'm thinking that this would be, we would need to kind of go down the rabbit hole in this one and understand, because I can't help but think that there would be an implication on the spec as well. If we go down with this, it wouldn't. I have the feeling that it won't be just a case of changing the implementation. So we should have a detailed discussion about it.
Yeah. Anyway, yeah, my high level request is, yeah, if we can make the memory features optional via build flag initially, I think that would be a good start.
Okay.
Thanks.
Thank you.
Are there any more questions for the guys? Not hearing any. So thank you, Marc, Olivier, for your session presentation. I think perhaps if you stop sharing, then Manish can share his screen and we can do the DRTM session. Can't hear you at the moment.
Yeah, can you hear me now?
Yep.
Okay, can you see my screen as well?
Yeah.
Okay, so this session, me and Manish Badarkhe will be presenting. This is not on details what DRTM is, but on as we have done a presentation a few months ago about DRTM spec and also promised implementation of DRTM in TFA by end of June. So we are going to present what all we have implemented in TFA and the patches, which stage it is, and we'd like people to have review and give feedbacks or maybe try it on their own platforms. So just a recap on DRTM. DRTM stands for Dynamic Root of Trust for Measurements, which begins a new chain of trust by measuring and executing a protected payload. This is useful for the cases where the number of components during boot grows. So this is contrast with the SRTM measured boot, which stands for SRTM, where we can have dynamically increased a number of boot components. It also reduces the attack surface and risk of executing untrusted code, and hence able to stop compromising the security. And finally, it does not have any dependency on previous chain of trusts. So we can start it at any time during the life cycle of a system. So this is the introductory picture of DRTM. So what we are covering now is it starts from launch, launching of DRTM, and then so the current implementation is focusing on preparing the system for DRTM launch and then handing over the data to the payload. So on TFA, the current status is we have quite a few patches which was developed with ATG in ARM, Lucian, and so he provided us with the initial proof of concept code, and we have me and Manish have built on top of it. So the patches are currently under review. I would encourage people to go and have a look on the patches. This currently is marked as an experimental, and once we have a complete implementation, we will eventually make it production ready, similar to what we do for any new features. This is currently supported on FBP, and our next target is QEMU. It depends how much help we get from QEMU maintainers or QEMU platform owners. We will provide with the initial set of platform APIs, but it need to be carried forward. There is also documentation how to set up the DRTM stack, and if interested, how to play around with that. So all the things has been mentioned here about reproducing it. So both the links mentioned here will be our work in progress. So probably when we store this presentation just for Joanna. Like by the time you store it, we need to change the links for the future. And we also have few CI configuration where we use pre-built DRTM application to reproduce or to showcase the execution of DRTM. And we also have a documentation for platforms, platform porting guidelines, what all mandatory APIs need to be implemented to let DRTM work. So I would highly recommend, encourage people to go and review the patches and provide their feedbacks. So what are the implementation, or what are the details of implementation we have done so far? So DRTM spec talks about two kind of implementation. One is firmware based and the other one is hardware based. So the current implementation is firmware backed implementation. DRTM spec also talks about having DC RTM and DC components at different exception levels, but the current implementation both are part of EL3. EL3 makes sure the precondition to launch DLME is met by ensuring quite a few preconditions has been marked in DRTM spec about to launch DLME, and there are a few here mentioned. The first one is only a single P is executing at the time. All the interrupts are disabled, non-secure interrupts are disabled, and also about all the non-secure pending transactions and disable SMMU before launching the DLME to achieve complete DMA protection. There we also have implemented the standard services, DRTM standard services. Quite a couple of them are not implemented yet, but the rest of them are all implemented. And the current implementation is coexist with the trusted boot. Though there is no, it's not mandatory to have trusted boot enabled in a system to have DRTM work, but the current implementation we have is it's both are enabled together. And finally, and also this this implementation covers the generating and passing the DLME data during its launch. There is crypto support and has calculation for various DRTM components. Last when we were presenting in March, we thought of having a different event log driver for SRTM and DRTM, but now we have managed to combine both together, and there is a single event log driver for both DRTM and SRTM. And finally, the platform hooks. So these are the platform hooks which are all documented in the current patch stack, which is mandatory to support DRTM on given platform. So one of them is retrieving the address map and attach it to DLME data, retrieving the base address and number of SMME to engage DMA protection. Also ensuring that no SDI events are registered before DLME launch, DRTM launch. We also have platform hook to retrieve the TPM features and finding the protected DMA protected regions. Any question so far?
Yeah. So in terms of TPM, are you expecting it to be a discrete TPM, or are you routing it to, say a firmware TPM, or either can work?
So basically, we don't have any hardware TPM right now. So it is really related to the platform. If they want TPM, hardware TPM in their platform, then they can use these platform APIs and provide the features of TPM via those platform hooks. But currently it is like very much firmware based kind of event log mechanism where the physical TPM is not involved for the FEP implementation. Is that
Okay.
answer your question?
Yeah. Yeah, that is.
Raghu, just wanted to add that there is an investigation going on within ARM around how to kind of connect the DRTM service to a TPM service, which might not be at EL3. And basically, without making the assumption whether the TPM service is a FTPM service or a hardware-backed TPM service, it's basically getting basically allowing communication with this TPM service in a secure partition through the use of FFA as a backend to the DRTM implementation in EL3. If you see what I mean.
So
Yes, that is exactly what I was thinking about. Yeah.
So I have captured that as the future work. The last point here. What exactly Achin has told.
Oh, great. Sorry to preempt you.
No. That's all right. That's all right. We were thinking of starting this discussion at some point.
All right, great.
Yeah.
Thanks.
So what does your POC do? Does it just hard code some features? I shouldn't call it POC. What does your current
It's no longer a
implementation
POC, it's the current implementation.
Yeah, so the current feature means current actually implementation in the FVP is not using it is directly publicizing the SHA algorithms and all those things via the platform hooks, not really using any physical TPM driver calls or anything like that. So it is basically using only the event log driver as of now. So what the information we are getting it from the platform is like what exactly the SHA algorithm we need to use. So accordingly, we calculate the hash of that particular DRTM components, and then we will just put that hash into the event log buffer, and that's where we stop actually currently. So there is no further things like to extend those PCR records and all those things via physical TPM driver.
That makes sense. Thanks.
Okay, so just a recap on all the SMC call support. So most of them are fully supported now, except for the unprotected memory, because the region-based protection is not yet supported, and closed locality, because as we discussed, there is no physical TPM support yet, and setting and locking TCP hashes. So these SMC calls are not yet supported. And finally, the future work. So the most important is getting feedback from reviewers, also getting it merged based on the reviews and how fast we can go. Support on QEMU, this is one action item we will be taking up, and we are happy to help any new platform ports for DRTM. Currently, there is just a CI configuration for the RTM. We will think of TFTF tests to introduce for testing the RTM features, and a couple of documents about detailed design. And once we are finished with the implementation part and the threat model for this, so this will follow soon, the design document and the threat model. And implementing missing SMC and platform hooks. There are few to-do items in the code which is marked in line. So that's part of the current ongoing activity. We are still in middle of finishing off these inline comments, which we have marked to do in future. And finally, as we discussed earlier, a discussion or to start a discussion internal to ARM first about how to use, how to move event log or TPM to FFA compliant secure partition. So it's still early stages. I guess Lucian is taking up that, but once we have something clear on that front, we will let people know about that. So that's pretty much it from me. The presentation was basically to let people know that the patches are up in the up for review, and please help review it and provide feedback. Thank you. Any question? If not, then I will hand it over to Joanna. Thank you.
I have a generic question, maybe a naughty one, but shouldn't the detailed design and threat model happen before the actual implementation? I mean, we treat this as future work.
Okay, so detailed design is already done internally. We just need to document it with the sort of the detailed TFA documentation, which we want to push as part of the patch. So the detailed design or the TFA documentation patch is not yet part of the patch stack. We are in process of pushing it. For the threat model, yes, I agree that we should do the threat model soon, but currently we are in the order of defining threat model comes later for just before. So one of the reasons why we mark some feature as experimental is we haven't finished off with all this basically threat model. Once the threat model is ready, this is one of the criteria of making a implementation non-experimental.
Manish, if I understand it right, there is an architectural threat model in the spec though, right? So
yeah, correct, Achin. Yeah, so I think already the threats are already mentioned in the specification, and I think when the ATG code has been done by Lucian, that time most of the threats mitigation have been already covered over there. But yeah, we didn't look it back, and actually we really need to look like which are remaining one, and
yes,
accordingly we have to provide the mitigations for that.
Yeah, I mean, my main point is that we won't be starting from scratch. We did some threat modeling as a part of the spec work, and right now it's an experimental feature. So I guess as Manish was saying, that this will follow. But there is a baseline. There is hope.
Okay, thank you. Good to know. Thanks a lot.
All right.
Right, but it is important to get the the implementations threat model done too, right? Because there's a bunch of imp dev stuff which can significantly in the spec that can significantly affect security. So yes, you're right. The architectural threat model is there, but yeah, this is really useful to have, at least for some of the other stuff. The other threat model documents are at least for me, has been super useful. So yeah, it'll be nice to have this.
Yeah. I think it definitely will be there. It's why we go through this sort of experimental phase where we want to share with the community the work that we've done. Our ATG colleagues had a proof of concept. We've tried to take it to the next level. Getting it installed or as part of a release. But we realise there's still work to do. Testing and various other aspects that aren't complete yet. So it's a journey, and the point of marking something experimental is very much to give you consumers downstream or partner platforms to be aware that hey, this is still a bit of work in progress here. We advise you not to build products around this yet, because we're doing hardening work and as well as the testing and the firming up the threat models and other things is all part of that work.
Understood.
Okay, any more questions for Manish and Manish? I did have an hour and a half because I wasn't quite sure how long the Q&A. Looks like we've literally just overrun a little bit, so I can give you all back half an hour if there's no final questions about anything. Not hearing anything. So thank you very much. The next tech forum, I think, is scheduled for a couple of weeks' time, when it's planned to be long-term service release topic. So please stay tuned and call in for that. I'm sure that would be another interesting discussion. And thank you, everyone.
Thank you. Bye.
Thank you.
Thanks all. Bye.
Thank you. Bye.